So I see we have our panelists already ready to get going. Very good. Okay. I'll just quickly introduce our panel, give a little topical overview, and mention one or two organizational things that are happening. Our next panel is focusing on data revolution, right? We've been hearing, this is not a new idea. The data revolution has been underway for quite some time, but it is gathering pace, I would say. And the question is, how do we manage and utilize large-scale ocean floor survey data? That's what we're going to get into. We have a couple of great voices on that. Just again, those of you in the back of the room, we do have a coffee break coming up after this next session. If you could return to your seats here and join us, we'd really appreciate it. And I'm just going to try to, if you're just wrapping up your conversations, try to do that very quickly and quietly, and we'll get going. I know it's difficult to come back after lunch, in the afternoon, and also after such an invigorating session. But let's try to get going. So, on this next panel, we are missing one of our panelists again. Unfortunately, Alina Dahlmann from the Ministry for Energy Transition, Climate Protection, Environment and Nature here in Schleswig-Holstein. She was here yesterday, but she was called away on urgent business and can't be with us for this session. But that doesn't matter because we've got a couple of really well-focused people. One of them you know. I'll invite our panelists onto the stage. Jann Wendt, who really needs no introduction. The person who is the driving force behind the Kiel Munition Clearance Week and lots of other things at North IO. Also, Patrick O'Keefe. Where's Patrick? Right there. Patrick O'Keefe is a staff officer dealing with space operations at NATO. He'll tell us maybe a little more about what he does exactly and how it relates to what our topic is here today. So, Jann, yesterday, you may recall in his presentation, talked about the incredible volume of data that is being collected through his work and other work too. And there's a question about how much data do we really need and what do we do with it? There's the quality of it, there's the processing of it, there's the storage of it. There are big questions surrounding that, but there's more and more of it being generated all the time, and we're finding out today how that is being generated. But what do we do with it? The question is, the warehousing, the analysis, the integration into operational planning. We're going to get into some of that just now. We'll probably shorten this session a little bit and extend the coffee break that's coming up immediately after it. So I'm just going to sit down and invite our speakers to get going. So let's start with Jann. Jann?
Okay, perfect. So, thank you very much for the introduction. I think after this very deep and honestly complex topic, I think we know where we're really standing. We're talking about some kind of little bit luxury problem that we are facing here with our topic of UXO. Nevertheless, it's a very important topic. We learned that we can transfer a lot of our knowledge also into this kind of domain. And one of the things is the dealing with data and also mass data. And I would like to dive with you a bit into this kind of topic, how we can also make use of cloud-native technologies to deal with this. I mentioned already yesterday, there are mega trends that we see, the industrialization of the ocean due to the energy infrastructures, grids, telecommunication and pipelines. We see autonomy, more and more data sets are generated, and we have connectivity. So the Starlinks of the world are now there, so we can also transmit data from the ocean directly. Maybe not in the bandwidth that we really need to transfer raw data, but we are hopefully heading there. I also showed this slide yesterday, so the complexity of the different kind of data formats. So we have a multitude of data formats. We are missing standardization still, and we have to address some kind of key challenges. So one of the key challenges we are facing is the topic of data harmonization. So this There is not this, unfortunately, one nice data standard, and there are reasons for this in the underwater domain. I think in comparison to space and satellites, which is already longer in productive usage, we are a very young domain, I would say, when it comes to sensors. There were several tries of bringing this one generic sensor format in, but unfortunately it didn't work. Many of the sensor providers have their own data formats, but this is something we have to do if we really want to work on scale with data, because data that we get doesn't come from one device, or there won't be this one provider who will survey the whole Baltic Sea with this one multi-beam. So we have to work on data harmonization. Another point is data exchange. How do we exchange data? How do we exchange sensitive data between the different kind of stakeholders, between the entities of the public side, between the private entities? I think critical underwater infrastructure is a good example for this. How do we make use of the data that the providers are recording more or less every day, and how we combine this with state-based data? And in the end, we also heard it's about data analytics. So data itself is not the reason why we do this. We want to have information that we are going to draw out. So, and that's something we have to work on. Yeah. So one of the big parts is data standardization. And standards, from our understanding, from the pure informatics side, are really the key for working in complex data-driven environments. Without standards, it's very hard for us. And that's, I think, also where we can learn a little bit from the defense and security domain. At least you have some standard guidelines, the STARNAX and XTAX, which we are partially missing when we are also working in the offshore private industry. What we also realize when we talk about data standardization, that cloud native technologies and ocean data at the moment, they are not 100%, let's say, compatible. Cloud did not arrive fully, I would say, in the domain of ocean data. I mentioned already alignment with NATO, for example, STARNAX or ISO frameworks is needed. One good thing is where we see a bit of cooperation is, for example, the Open Geospatial Consortium, which is in our and my geo world, actually the standardization organization. They are participating in the REPMOS exercise, so the robotic experimentation exercise, together with the US Navy, and we are also in discussions with them how to make use of standards and apply them also in the ocean and water, underwater domain. Then we have to talk about software architectures. How do we build software architectures that are scalable? Because we have more and more data, so we have to build technology that's cloud agnostic, that works everywhere, that works in scalable environments, that works in secure environments as well. The technology has to be modular, so we have to decouple components when we work about this. We have to incorporate big data approaches, and I will show some examples about it. And we have to think about how we store data. This is one big part of also our work. The data that we receive from the sensor, that's binary data very often. And this binary data, one very good example for the ones who are dealing with multi-beam and side scan, the XTF format. Very much known, comes from the 1988 with 42 revisions. Yeah? And the cloud world was not existing when we were in 1988 creating the XTF format. Yeah? So, and it's still very much in use. Yeah? So everyone who deals with side scan data uses the XTF format. So there is at the moment no really good fit between these two worlds. So there needs to be a translation between these two worlds. That's why we need to use different kinds of data structures, transform them into cloud native data structures. Locating information. And I mean, we work also for different kinds of industries, private, also the public sector. Which kind of data does my organization have? And where is this data located in the world? Sounds like an easy question. Unfortunately, it's not. Now, very often, still data is managed by Excel lists if we talk in this complex world. So also we have to make use of other technologies to locate data in the world. Where is my side scan sonar data? Where was my side scan sonar data that I recorded 5 years ago? To make also the possibility of getting some kind of change detection. And we are, for example, testing some technologies that Uber provides. So Uber provides a technology that makes the globe into small grids, very efficient, and you can use this kind of technologies also, that this kind of cloud technology enables use for the underwater domain. So lots of stuff is done, we just have to transfer it also in our underwater domain. And we have to come to big data approaches. So when we talk about big data, we are talking not about 20 or 100 XTFs that we process in a manual way. We talk about actually highly scalable systems where we use data formats that can be terabyte and petabyte size big, which we run through multitude of servers at the same time, and stitch them together afterwards. So simply reducing the time of data processing. There's also, we will participate in the REPMUS exercise, and we see there's a very, very big need also in this domain, but also in the industrial domain on both sides, to make this data processing flows shorter, because in the end, it's time, and time is money, or time is risk in the maritime defense and security world as well. So just one picture I showed yesterday already, what's the difference of treating actually maybe a side scan sonar in a non-classical way. The classical way is the rasterization of a data set, and then you have a 10 centimeters resolution data set, which is also from a quality not too bad, so you see this kind of objects. But the same data set actually provides much more information if you treat it, for example, as a point cloud, so in a different way. Same data set, I don't have to use a different technology, it's the same data, but we make full use of the full capabilities of the data. And that's for sure when you feed the right picture into the AI, it gives you a different story and a different kind of information set. And then we are coming to the part for sure of AI-based analytical approaches. So we want to work on the raw resolution. We want to work on the raw data as well, and not the rasterized data, so that we can make use of the full scale data. We want to enrich it with statistics. So there are some fancy machine learning approaches to not just only use the data itself, but to use derivatives of the data to make a more holistic picture. And then there are also very interesting technologies for anomaly detection. So an AI autoencoder. So this autoencoder models the seafloor, and when it sees something that doesn't look like a classical seafloor, it says here could be an anomaly. And that happens then on a GPU base. So there are lots of interesting technologies that we can apply, which are used in different kind of environments, but at the moment maybe not that much in our world. We had yesterday a very interesting talk, and we went already into this with Dorte and Peter, and also with Thorsten about the topic of quality metrics, how to assess the quality of data. And I mentioned yesterday that we had this BASTA project, which I would still say was one of the most successful research projects we also had, where we tried to, mainly Thorsten's and also partially Daniel's work, was to provide a questionnaire to experts to do workshops and to create guidelines based on user input, based on industry input. And that's something that we also have heard as of today, also Fabian mentioned it. We have to listen in the end to the users, because they are the ones who are using this kind of technology, and not to work in our little lab here and say this is something that works. So in this project, there were, let's say, 4 representative munition objects shown and characterized from the size and dimensions. And we identified in this project 41 parameters for 5 sensors that talk about the data quality. So there's side scan sonar, multi-beam echo sounder, magnetics, sub-bottom profiler, and electromagnetics. So then we conducted expert interviews. Dorte was also part at that time of the expert interviews. A paper was written and it was published where we checked which kind of quality metrics really describe in a quantitative way the data itself. Because we don't want to do it qualitative. Qualitative costs time. We want to do it in an automated way. And just to give you some examples here, some very simple examples, but they are just important. Data point spacing. If we don't have many data points which show an object, we simply won't find it. It's a simple measure, but also therefore we have to understand the raw data. And we also have to use big data technologies to make this fast. Footprint. We have a very, very big footprint. It's not so easy actually to get a clear information about the object itself. And for sure, we talk about measurement uncertainty. And in the end, what we want to get, and I think that's something that also Dorte and Anja also yesterday said, we want to get a more automated way of understanding what is our risk as well. Yeah? If we have a highly automated map here in this case, and we say, okay, in the area where it's green, we can detect objects that are 10 centimeters or below. And in the areas where it's red, we are going the size of 50 centimeters or above. Then we can very easily exclude also areas, especially if we already have existing data. So, and that's also coming to the end. So there are quite some similarities also between the UXO clearance topic and the defense topic. In the end, time is a crucial factor because time is equal in the defense domain to risk, and time is equal in the industry to money, to make it quite simple. And the question is, which risk are we willing to accept, yeah, and how much time do we have to reduce this risk? And also I think that's one important learning for us while diving deeper into this world of the defense and security domain, especially in the terms of minesweeping. There are tremendous overlays in what we are doing, a bit different ways, but we can learn, I think, a lot from each other. Thanks.
Thank you. So, a lot to digest there, I must say, for me being not really the data expert, but still absolutely fascinating. I'm sure there's going to be a lot of questions concerning that in the room. Patrick, would you take the floor, please? And first of all, tell us a little bit about what you do, about what your position is at NATO and what you do.
Thank you very much. Hi, my name is Patrick O'Keefe, Irish name, German accent. I'm a reservist in the German Navy and seconded to a NATO Center of Excellence, more in a minute. Can you please jump back to the first slide? Because it already takes, all the surprise out of it. No, all the way to the first. So you can see we don't have a PowerPoint preparation department in our center. I do it all on my own. So I come from the business segment of turning data into value, turning into military operational value. You probably have heard that slogan many, many times from so many different IT companies and so on and so on. Usually I'm in uniform and I try to bridge the gap between the worlds and to turn that slogan into something tangible. Please do the first slide. First slide.
So we're sorry about this.
Or just the arrow keys, number 1 up there. All right, thank you. Yeah, that's me. I'm working for a center, that's why I wanted to have the first one. Center of Excellence for Operations in Confined and Shallow Waters. It's a long title. Even though I'm a reservist in the German Navy and usually I'm wearing uniform, just a small disclaimer, I'm not speaking on behalf of the German Navy, and same time I'm not speaking on behalf of NATO, because this Center of Excellence is comprised and consists of representatives of different nations within NATO and sometimes even outside NATO, and under the umbrella of a steering committee. So we are responsible to the member states, NATO members, but not to NATO, not to Germany. So that gives us a huge degree of freedom. We are not bound to procurement processes national-wise or NATO-wise. We are not bound by IT regulations, even though our IT environment and our personnel is all certified, classified to go all the way from unclassified to deep, deep red. So that gives us the freedom to work with companies and play with things and test them and get them quickly connected to things to get to the feedback of the operators, to people in uniform and non-uniform to work in an environment like this. NATO has 30 plus centers like this one, big ones, small ones, different dedicated areas, 5 or 6 for the maritime environment. This one coincidentally is in Kiel, so just a couple of kilometers in that direction, if I'm not mistaken. However, our office is usually a bag with a notebook, and then we go to exercises and so on. I also want to highlight that within our center, we have different personnel from different nations, but also we are always happy to work together with companies, research institutes, and so on. We work with research facilities like the aerospace research centers in different nations and so on. We are not bound by one nation. Furthermore, what you see here is just a map with dots, and this is basically what we do. I wrote it here down like this. It's turning, well, in other words, create dots on a map. That's what I'm doing in my professional background for many, many years. And now we are stepping towards in the modern times. We are trying to get more and more data involved, as mentioned before. Thank you very much, by the way, because you use many, many words and topics I would like to also touch upon a little bit. It's nothing new to create dots on a map, to create an operational value for operators, and hopefully something that really has a tangible output afterwards, on scene. I've done this for quite some time also with the Israeli and the Ukraine IMINT team in the context of the current crises. And that was quite impressive to see how the tempo to get data into the battlefield is impressive. And technically it works. So long story short, my presentation could be shortened. If we take everything we have down here, put them in one room, one data platform, problem in the Baltic Sea could be solved. All the hybrid thing with Russia, we can create something, an awareness that might deter the actions of Russia in the Baltic Sea for sure. However, we are not at that point, unfortunately, for many, many reasons. And I would like to elaborate a little bit, just to pave the way for the conversations afterwards. Since I'm here, I'm trying to give you a little bit of feedback and expertise, experience what we have done in the last years. And one of the titles is Seabed to Space. Sounds great, right? You probably have seen that from NATO HQ, you have seen it in documents and papers and so on. I don't care, it just simply describes what it does. It takes data from the seabed, it takes data from the air, from space, put them all together, problem solved. Sounds easy, but it isn't. Another one is multi-sensor data fusion, because still people sometimes ask, yeah, what exactly do you do in this environment and with the teams you have and so on. Multi-sensor data fusion. Okay, helps a little bit. It means we are mainly working with coders, with programmers, with IT people who have nothing to do with the maritime environment, nothing to do with the military environment, and therefore there's a huge gap in cultural and contextualization of the information. It's not a threshold that it can be overcome, but it takes time. It takes time to get them on board. On the other hand, it's a huge opportunity to get something that hasn't been done in the usual procurement process of the military, because we are thinking in straight lines. And if some IT people come around at the age 25 and come with ideas, we would usually in the past would have said, no, thank you, go to a big company first, work there, and then you go to us. We have worked with the big companies, with the big letters, with the small companies, with long letters, and with a colorful mix of different solutions to bring on the table. I have a few slides with me. They help me a little bit to structure what I'm going to say. If you have any questions, please feel free to raise the hand. It can drive the way a little bit, but also in a moment. And as mentioned earlier, we don't have a social media team in our center, so the slides are not 100% perfect with all the colors and so on. So some screenshots to help me to go through the next minutes and help you to understand what I'm saying. Next slide, please. Number 2. Yes, buzzwords. I usually try to use this slide to say, yeah, we are well aware of all the things that are going on. Some maritime pictures, underwater vehicles here, but the other things are like quantum computing. For quite some time we have looked at that one, also in Silicon Valley and so on, because they are going to solve everything. Artificial intelligence is about to solve everything. Autonomous systems, talking about this for 15 years already. Back in the days when I was in aviation, we already had autonomous systems in the air next to us in a plane. Not much has changed, and at the same time a lot has changed. Environmental characterization, contextualization I usually say. But space, me personally, space is quite interesting, because from that perspective, as well as for the others, a lot has happened. A lot has happened in the IT environment, in the space environment, and everything is more accessible than before. From our Center of Excellence, we look at these topics and we try to get hands-on feedback and information on these different buzzwords, working together with the research entities, working together with industry partners and so on, as we are not bound to the procurement processes and not inflicting with any national laws. That's super helpful. Next one, please. Thank you. I tried to put it down into a few categorization where I come from and what I'm talking about here. It's in general maritime situation awareness as a Navy officer, but also sometimes for rapid environmental assessment, for example, for special forces. Hey, we need some current data because we're in operation tonight. And under this umbrella, we can access a lot of data that is quickly accessible. For example, high resolution space-based data, synthetic aperture radar, for example, with 0.15 meters per pixel. Quite amazing. Has been 5 years ago, it would have been a national classified material. Now you can buy it for 1,000 bucks and task it in a bus. I did it last year. I was sitting in a bus here in Kiel and was tasking the satellite for the night. The picture will be in a moment. And working together with some special forces, different nations. The rapid environmental assessment is a term that is quite useful to describe, hey, we quickly need data. Anti-submarine warfare, of course, the golden branch of submariners and so on, and allocated to that area. It's also a little bit going back in the data, historical data, see what has happened in the past, to create systems to find the submarines with modern ways. And post-mission forensic analysis is also a term like, what are we doing now? Are we looking for live data? Are we looking for the past data? Both different things. Just a few categories to shape the mind for the conversation. Next one, please. Yeah, that's the blueprint. That's it. It's not fancy. It's something from left to the right. It's about basically get all the data you can get, put them together in an environment as mobile and flexible as possible. I have Starling on this one, but we can use others as well. With notebooks, things like this. You're not seeing like complex schema of classification systems and so on. That's not what we do. That's up to the nations. Of course, in our center, we can work all the way up to NATO classified and so on and so on. But we try to avoid it because most of the data is unclassified, commercially available. So why to increase the threshold for partners to contribute to partners by national laws, even though the data itself comes from commercial sources? I understand many of the discussions, I know, but still, we try to avoid it for as long as possible, to be as shareable for as long as possible. And the output, as mentioned in the previous slide on the right-hand side, are the different categories and more. So basically, the blueprint of where I come from and working with a lot of coders and IT people, and this one is getting data from the left to the right, operational, military operational value. We assess the military value by exercises, for example, Baltops at the moment, Northern Coast, the usual ones in the Baltic Sea. We have been to REPMOS many times, started off in REPMOS with small portions, and iteratively went over to bigger systems. And by that, we learned a lot to talk to the companies, small, big, and so on, and ask the right questions. Because at the beginning, we were not asking the right questions, and we sometimes still do not ask the right questions yet. One of the filters, for example, for the IT nerds in this room is API filters. I have to say it again and again. We had meetings where company data, commercial data companies, big and small, wanted to sell us, as traditionally they did in the past, huge amount of data, accessible via links, via web logins, or attachments of emails, or FTP server jobs. And from our team, we say, no, not anymore. We don't do that anymore. Either you have API or not. If not, go out, go home. Because we need tempo here. And with tempo, I mean not days, even our own system gives us days, I mean seconds. I can have the data accessible in 12 seconds. So a whole satellite image downloaded and processed for ship detection in 30 seconds, done. So this is the way to go, right? So I'm not doing this. This is one of the filters in this slide. We say, if you have an API, join us. If not, do it and then come back. Same time, we need to have it to go to the different national systems. We are not competing with the national situational awareness systems. Every nation has a different situational awareness system, not only one, plenty of those. And we are trying not to compete with those. We're trying to be in the middle, middleware, another buzzword. But it helps. Next one, please. That's just an example, because depending on the audience here and so on, what is this guy talking about, this is just an example. Looking back in the operational environment with Israeli counterparts and Ukrainian counterparts is the question of operational usage, for example, of one data source, space-based data, or another data like distributed acoustic sensing, or all the other data sources you can imagine. Some of the data sources only come by maybe one or two times a day, or even once per week. And in the past, in the conversations we have with the different data providers, they said, we can provide you data set once per day, twice a day, but we don't know if it's of any operational value for an exercise operation on that day in this time frame. And we try to puzzle it together to make a mesh, because simply for me it just makes sense. But it turns out if you take one satellite image from that company, another Seabed survey data that comes in freshly via API from the same day, side scan SODAs, and so on, and put them all together like a puzzle like this one, from the left to the right, from 0 to 24 hours, then you create your near real-time picture. And it works super well. Just last week on Friday, we had an all-in day during the exercise Baltops, and turned out that with the different data providers, the big ones, the small ones, all together, Airbus alone, Max alone, Planet alone cannot provide this, even though they all say it on the slogans, maritime detection and so on, I know. But if you have a satellite constellation that provides you only a handful maximum, maybe 2 images per day, for Navy guys, it's not enough. It's gone, it's old school. Even though you get it in 30 minutes, what about the next 12 hours, right? But together with the small ones, with the newcomers, with the different sources, radar stations, Unseen, that's French company, they scan for radar frequency scans with satellites. Pretty amazing stuff. They scan for the navigation radar systems of ships and not for the AIS. Helpful. Russia turns out AIS, well, they still want to look with the navigation radar. So everything put together, in the bottom line, you can see near real-time, sometimes real-time picture. This is what we do for the live data sets, but everything that is created here goes back into the archive and for the past, for the traditional historical data, which is super useful and needed for all the other use cases. Unexploded ordnances underwater, seabed analysis, and so on and so on. Anti-submarine warfare going back, hey, we have a contact, or we had a contact 2 weeks ago. Now we try to verify the data and analyze what we got with the acoustic sensing and so on, put them all together, and then you can make a picture out of this. But it's a huge amount of data. The distributed acoustic sensing alone, scanning with fiber optic cables, creates, for example, 2 gigabytes per second out of this modem, the interrogator, per cable. So that's a lot of data needs to be processed. It cannot be done by humans anymore. Next one, please. So, yeah, this is one of the pictures. So this is, we created also own dashboards with our IT people to test and verify things. For example, big companies tried, and also small companies tried to sell us ship detection algorithm. Works, but you can find it on GitHub for free. So you don't need to bother, to pay the big money. You can test it. And then to ask the right question and go back to the companies and ask you guys, what do you really need for what context? In this case, for example, ship detection algorithm on GitHub, done, integrated with the right IT team overnight, and can be done on satellite imagery in 30 seconds, clickable, used on a mobile phone, and so on. So it's possible. We do this not to provide the best maritime situation awareness picture. We try, as I said, we're not competing with the national ones of the different nations. We try to support, create a base of expertise. As in the COE, we have the degree of freedom, and to do these things, ask these things, and go back to the nations and partners and say, hey, maybe have a closer look at this. And that's where, for example, also the platform True Ocean have seen before is super helpful, because it's another platform that is focused originally for underwater data, but comes in a moment. Next one, please. Ship detection algorithm. We test our own things, put different AIS sensors together. At the moment, also connecting underwater drones with the video streams and so on and so on. Put them all in one platform. Next one, please. And I think that's, I wanted to show this one. For example, high-resolution synthetic aperture radar collections from space. Here you can see the quality, for example, has changed a lot. 5 years ago, unimaginable. Getting commercially because either big prices under huge NDAs, or Trump is tweeting them on Twitter. If you remember this one picture, if I'm not mistaken, from this Iranian test site that exploded, and afterwards people said, oh, he is disclosing national assets and what quality they can acquire. Well, in the community it was already known, but now you can buy it for $1,000, smaller resolution like the left-hand side for $500, and task it in the bus with the mobile phone. And response time like 60 minutes to the satellite overflight and 30 minutes to delivery, so 1.5 hours. Fast tracks are available, you probably know in other areas if you ask what the company is, right? This is something that is super nice, super helpful once, but you need it continuously. And that's a lot of data, and you need to put them either as a picture or point data. What do you want? Do you want to already have the detections or the raw data? At the moment, and with the experience doing these projects and with the different stakeholders are involved, we came to the conclusion it's exactly what Jann just said, raw data. A couple of years ago, we have thought, no, raw data we cannot manage, so we need to go to automated processes. However, it turned out if we take the results of an automatic process from different sources, sometimes there's no match, sometimes it's not synchronizable. So we try to go back a few steps and try to understand the raw data because there's beauty behind it. There's so much else you can do with the raw data. This type of image you can see, traditionally you would see and look at it as a two-dimensional picture, right? You see it, good quality, nice, I can recognize a warship, I could classify it, well, some nerds can even identify it. Guess what? With this image, you can create a 3D dimensional visualization, a simulation in top quality that can feed the data of drones in the air and underwater, if you have the bathymetric data, and can operate based on this one. Once you have processed this, automate this process from tasking, collection, transforming the 2D image into a 3D image, environmental simulation, put it into a drone, pathfinding process are solved. I have seen it. Even the salespeople of big companies sometimes do not know it, that the technicians are able to do it. So please afterwards talk to me if you're interested in this stuff. Amazing, beautiful. Next one, please. Oh, yeah. This is another example of this platform thing of different data providers where you can use satellite images to process it automatically to find the ships. This is, I would say, state-of-the-art 2025. This is what's happening right now. Me personally, I would have thought 5 or 10 years ago it would be available already because we have AIS for 25 years or more. We have internet for 25 years. We have IT services. We have automatic filters, AI or complex if filters for quite some time. For the maritime environment, it's enough. But just now, in this last year and this year, finally companies and the processes are so far advanced that we do not need the people in the loop as much anymore. So we can really reduce the workload of the people, which is super helpful and necessary, as we are not getting as many people anymore as we did for earlier for the assessments. Same time, this gives the ground for what? And here comes a little bit the bridge back to this topic, underwater. More and more satellite constellations are able to penetrate the surface of the water and to go underwater. Also nothing new, right? Bathymetric data, space-based sensors, and so on. However, the algorithms to work with it, they are shaped better and better. And some of the companies, they're asking us, hey, do you have any use for this, bathymetric space-based data? Because we don't know what to do with it, because they're looking for tanks. They're looking for artillery and ships, airplanes, and a little bit of ships. And we, of course, said, yes, we would like to have it. So this is a trend at the moment, and I recommend to you to reach out to different sources you have and ask for it. We need it. The constellations are out there. They simply do not know the operational value of it, surprisingly. And everything that the IT people learn from working with these data sets can be adopted to work also with the underwater data. As again, the IT people usually not work in underwater, they are not working with navies, and they are not working with drones and so on. Next one, I think that's the last one. Yes, yeah, exactly. Can you switch that over to that one? Yeah, oh, it's already active, sorry. That's one from Baltop's exercise a couple of days ago, where you can see, for example, the ships in port, and on the left-hand side, and on the right-hand side, you can see when the ships have left the port. Usually, in the past, we have done this with pixels. You were able to see a cloud of pixels, and then you guess the ship is there or not anymore. Right? We can all agree the quality is astonishing now. And again, done in the bus, task in the bus, and here comes another thing, and then I will finish in a moment, but I think we have enough time, is also the experience working in the system. Coming from a military system with all the organizational benefits, and deficiencies, pros and cons, is in the past when we have asked for satellite data or space-based data or other data sources, it takes days or weeks, while you can ask sometimes with a quick assessment, maybe a few hours in the best case. These things come in within 30 minutes to 45 minutes, in the best case, sometimes with 60 plus minutes. Other providers are still in the hours, but they will learn it this year by the hard way that it's not possible anymore. They needed to do it by 60 or less. However, what do you do with the picture? In the military system, usually there's a huge organizational arm to work and process the data, and it takes days and weeks, positions, there are people well educated to do the job and so on, and they can derive out of these images and Seabed images more than I can see with my eye. Sure. but tempo is required. I'm not interested in any small features. I'm interested in the ship there or not, if there's something on the ground or not, is it still there? Is there a drone from Russia operating over a cable at the moment or within these hours, or are they gone? If I get the picture and the assessment in 3 days, I don't care about this anymore because they are gone and I want to know if there was a drone or not. So what I'm saying here is, was super helpful. I get these images from the companies still in a orientation and type format, data format and so on, that our team still needs to process it as well and so on. But thanks to these guys, it works pretty well. Next slide, please. Yeah, I mean, we learned, we got to know different data platforms, for example, also connection with other service nodes, IO True Ocean, drag and drop. I was not thinking about the possibility to take a high-resolution satellite image, just drag and drop and put it in a platform. It's orientated and merged with all the other data sets. And this is something that increases the tempo. And that was super helpful during BALTOPS and during Task Force X-Ray at the moment as well, and in other exercises and operational preparations, put it this way. Yeah, I try with this last slide, I try to bridge the gap a little bit more to the underwater data, to the seabed data. As you can see, this is also, I was talking about space-based data, but at the same time, we are moving forward to integrate also the seabed data and everything in between. That's why we're also looking at dust, because we are interested in what's happening between the sea floor and the surface. Dust is super helpful with this one as well. Yeah, that's so far the story. This is kind of the kickoff input, and I'm looking forward to the discussion and the questions. Thank you.
Thank you very much, Patrick. There are a couple of ways we could approach this, because I'm not a data scientist, right? You guys are data scientists. There are data scientists in the room. What you've just presented to us has applications, obviously, for what this conference is about, for detection, and ultimately then for clearing the unexploded munitions, and also particularly for the protection of critical infrastructure. So, both these strands of our conference are very relevant to what you're talking about. But I have a couple of just basic questions, non-expert questions. But while I ask you these questions, I would like you to reflect on what you just heard from the other, right? I would love for you two to kind of talk to each other on this panel about what you just heard from each other and how it might be applied to the top two strands of our conference that I just mentioned. So my first question, as a layman in these terms, would be for you, Jann, and it's just a really fundamental question because you addressed questions, concerns surrounding data standardization. You went into about sensor providers having their own standards, and we're dealing with this incredible volume of information, data, which much of it was already there in the past, and we're trying to put it together and make something sensible out of it so we can use it. And my first question to you would be simply, why? Why is there no data standardization at this point? By now, you would think that it would be in the interest of everyone if they would collect and collate and agree on some sort of standard. You mentioned the Open Geospatial Consortium as a platform, or at least a place where maybe that is happening. But so just first of all, what's stopped this from moving forward now? First of all, just very simple question.
Yeah, I think Ocean was never 100% in the focus of any way of data standardization. Ocean is a specific group of people. It's still a young domain if we talk about very high resolution data, so the very high resolution system. I mean, side-scan sonars are applied already for ages, that's out of question. But when we talk about very high resolution multi-beam data, these point clouds that you see, these three-dimensional data sets, it never really started that a standard could be applied. There were tries. I mentioned this generic sensor format, but satellite and space already had more time, I think, to work on this kind of topics, and there was a bigger focus on working on this kind of topics because it's simply older, the whole technology. I think the sensors also, when we talk about underwater data, they are very complex. very many of them are research-driven, then developed from a prototype into a workable system. We are still also partially missing a consolidation, really, of sensor manufacturers, I think, in the underwater domain. Partially we see this. There are bigger players like Kongsberg. From time to time, they buy actually also companies like the smaller ones. And then you have one more data format which has to be supported for quite some time. And the OGC, for example, it's a good example. They now reached out to us. I think they saw some stuff that we were doing, and they also heard that we will participate in the REPMOS exercise, and they will be also there because their interest is growing when it comes in terms of ocean data. So, and I think that's also because the geopolitics is changing. So the spotlight is more on the ocean, more also in the underwater domain. There are many people who are working for decades already in this domain, but now I think ocean is getting into the spotlight. Underwater data is getting into the spotlight. It's getting high volume. It's getting very usable, and I think it's still a process until also the Open Geospatial Consortium really is taking this. So I'm hope that there will be a standard because it would make life much easier and much cheaper. But I don't think that we are there. Just one more example. At the moment, the NATO CMRE is working on trying to establish a new sonar data standard. But it's a small group of people in there. And I'm almost sure the output that we will see there won't be the future standard that will be also applied by industry in this case. And there we have to be careful not to have 10 tries of making standards, because then we have 10 more data formats. But this big move is still missing. But honestly, I also don't know who can do it.
You know, I'm wondering about this. I mean, again, approaching this as a layman, and I look at how standardization has evolved in history, you know, just in terms of how we measure things, or you know, bringing it up to today. I mean, a very banal sort of illustration. How we charge our cell phones, right? You know, just agreeing on a plug for a cell phone, it took the European Union to come out and say, okay, manufacturers, look, guys, you're going to have to agree on something. With, you know, okay, this is a very simple example, but eventually you had an authority, a regulatory authority, step in to say, industry, this is what you're going to have to do. Figure it out. You're going to have to come up with one common way of doing it. And I'm just wondering, is there space here for a regulatory authority or for some international body to come together and say, let's agree on standardization of data for mapping the oceans? Do you see potential there, or where will the impetus come from? Where do you begin with that?
I mean, we are discussing here about who's responsible for UXO or critical underwater infrastructure, yeah? And even there is no answer to this. And this is, I think, even a more pressing problem than finding a data standardization part. I mean, the community, there is an active community, and I think really the OGC is the Open Geospatial Consortium. It's the community to work on this. They took this up actually in a conference in their member meeting in Mexico. So they asked also from me from a small video message where I describe also what we will do at REPMOS, because the interest is coming. And I think the community itself has to start to evolve to work on this. But there's for sure also an interest from a developer of a sensing system to keep it in some way proprietary, you know, because it prolongs the value. It prolongs the value chain. I mean, Apple is a good example. Yeah.
I was waiting for this. You know, there was a question. I was kind of moving towards that because there are proprietary concerns here. It's like if you're collecting all this data, you put together the sensing equipment, you've sent it out there, you've gathered it all, you've put it somewhere and stored it, you've analyzed it, you've filtered it, you've tried to come up with some usable information from it, not just data, but knowledge from this. We're talking about knowledge in order to then apply it, in order to then achieve something. And I was wondering, there must be a tremendous proprietary aspect to this. I mean, also for your company, you know, you provide a service with your data. I'm just wondering where that goes. Anyway, perhaps we can reflect more on that as we go forward. Patrick, your you're approaching this from a really broad perspective, right? You know, when you mentioned from seabed to space, and we talked today already about sensing underwater and sensing above water, different ways of trying to gather data about what's on the seabed for removal of UXO and also for protection of critical infrastructure. Do you see some sort of standardization in the way that this is approached? I mean, things become vastly more complex when you put all of these different levels together. Do you see standardization coming?
Yeah, good question. So first of all, coming from a military organization, right, national-wise, but also in the context of NATO, NATO has standardization in DNA. I mean, it was one of the reasons why we need an architecture to get different standardization between the nations to create a defensive and a deterrence posture. So basically, everyone who's involved in a military environment knows there are subgroups and groups and working groups on standardization in different types and formats and colors. So in many, many ways, there are processes ongoing on a standardization already on different aspects. There are sometimes NATO working groups you are not aware of. You come coincidentally across and somebody's working on these issues and then you're surprised, try to connect them and so on. What I'm trying to say here with this is there's a constant effort, and small efforts can create a solution for everyone, or sometimes big consortia create something that unfortunately will not get into the system. This is a reality. I think it needs to be accepted, and you can hope for the best. But at the same time, you need to be prepared and to be flexible. Next point to this one is kind of the philosophy of standardization. Looking in aviation, we have clear standardization. They are so clear and rigid that, for example, even Airbus 777 or 787, they need to still adhere to standardizations of back in the 80s. And you could argue, well, it's kind of hindering the advantage of the militarization of the systems, why the planes are still so heavy and so on. They could be smaller or lighter. So there's always pros and cons. In this case, I would say the best solution is get a team of IT people involved, all the way. As you said, data scientists, for example. I'm not a data scientist. I'm an aerospace engineer by trade and flew a few flight hours in the military, that's it. But what I've learned is, as long as you have one or two trusted IT people in your vicinity floating around, you can solve everything. It sounds amusing, but it is the way. If you have really good people within your team or good structure, there's always something we are not aware of this is. Give me a night in a hotel and I can solve this. Well, I'm exaggerating. But when it comes to standardization, maybe there is not a standardization, but that team is capable of looking at the connections of the data and get them involved in a larger system and get the value out of it. And maybe something that a standardization protocol would have declined. Even if you put a standardization around the data source, maybe some aspects are fading away. So therefore, I would say a mix, flexibility, but still hope for a standard to communicate with the others and get quick results. I hope that's something to work with.
Absolutely. As I've already indicated, I'm going to ask each of you now to ask each other a question on the basis of what you heard in that presentation. And then I'm going to open the floor to questions from all of you. So get your thinking caps on. And first of all, let's have Patrick. Do you have a question for Jann?
Yeah, Jann, we know each other for 1 or 2 years now, not too long. So the way we talked about it, and to each other in the last years was you made a journey and gathering experience working in this environment. I did. Knowing what you know now, especially in our conversations, what would you have done differently 5 years ago, 8 years ago, 10 years ago, approaching this topic, especially approaching the security and military domain?
I think a very, very good question. I would have gone earlier into this knowledge because there's so much overlap I'm just starting to understand now. Yeah? The world is not black and white, and there's not the, let's say, green perspective, environmental perspective, and the military or defense side of things. There's interconnections in everything. We also heard yesterday from NATO, from James Bergeron, the Taiwan conflict and what would it imply actually on the chip actually production in the world. So there's tremendous interconnections, and especially the last month that I'm also more and more involved into these REPMOS exercise discussions and how how the work is conducted there and why it's conducted there and under which kind of constraints it's conducted there. Yeah? So when you have to feed a ship that has systems from the 1980s with data, so that's not the big data that you can give the ship and then give it to the ship and they can work with it. So you have to work in a very, very constrained, let's say it, environment, and this makes life complicated. Yeah? What I also would have been great to know earlier how complex this data is in the end. I mean, we started quite naive, our technological development, I would say. In the end, it took us 4 years, and not just 2 nights with 2 programmers. I would argue that it's possible. Took us 4 years to build a basic technology that is able to convert into some kind of internal data standard for us. And we talk about, I don't know, 20, 30 formats that we are supporting in our technology on a production level. Because I think that's also a difference between really productive technology and prototyping technology. In prototyping, you can very fast show something, but when we use productive, or when we need to have productive technology where big investment decisions are based on, so risk assessment is done based on this, when lives are at stake in some way, when I want to have the risk of a ship passing a route, so I need productive, proven technology. And prototypes come to some kind of limit when we talk about edge cases. Yeah? So I think that's my perspective there. What would be, for me, of interest when it comes in your direction? I mean, you came from the space and satellite direction, and you are now diving into the water. What were your findings on this road? Did you see what I just said in the beginning, that there is a better standardization in the space than in the ocean? Did you also feel this, or what's your perspective on this?
Yeah, I need to think about this. But first reply is, indeed, I came from a different environment, even though I was involved in the maritime patrol aircraft business, looking into the water, deep into the surface, looking for data spots underwater. So that was kind of still in the daily work, if we had flight hours. But changing the positions and so on, it was surprising to me to see in the military service where we are at this point, because I assumed we would have been more advanced, because we have Instagram sending me the right pictures I want to see from Minecraft and whatever. So the algorithm knows what I would like to see in a big data set. So I thought and I assumed maybe now we are already in a position where we can use automated situation awareness systems that gives me the information that at least the department is looking for. And then for a short time in a specific position, I was working with the underwater teams that are analyzing the data from underwater, and I was surprised how the data is still in silos. I thought they were better connected, even wearing a uniform in the system. I assumed they were better connected, and that brings me back to the answer I would like to give, to question a little bit more. I would have liked to question my own assessment and my own understanding of the system, because for too long I assumed it would be more flexible. So that other way around would say, whatever you can learn in one area, in one domain, either it's in space, in air, surface, underwater, or somewhere else, it's always helpful to use this knowledge and to go somewhere else and ask the same question you would ask in your domain and see what kind of results and what kind of answers coming back. And if your gut feeling is saying, it doesn't make sense to me, ask again, and then the beauty and the wonders came out. Of course, I said 2 IT guys in one night and you can create a good system. We're prototyping, of course, but to get the system to get a prototype into the system with sustainable and usable for many use cases and so on takes a lot of time and planning and so on. And it's still the same. Planning, talking to people, asking your own hypothesis, and iteratively approach to this one. So all these different things together have still nothing to do with seabed data, right? There's nothing to do with space data, nothing to do with aviation or military. It's just kind of basic project management questions into an environment where then, once you apply these methods, go then to the experts and try to ask those questions and get them on board and try to make everyone comfortable so that they can work creatively. This is something I would have liked to see earlier, many, many years ago already.
I would have one question.
Go ahead.
How do you see, what's the way of fast-tracking technologies from different kind of domains into your world? How should it look like? I mean, there are processes in place. I think they are partially a bit lengthy. I mean, there's also a lot of work is done at the moment to maybe provide other ways. But how would your perfect fast track of bringing new innovative technologies look like?
Of course, in this position, I need to advertise different new things in different systems, different nations, innovation hubs that are turning up from the NATO environment, innovation hubs, and so on and so on. They're super helpful to shape the use cases. For example, a small startup, sometimes you say, but maybe a very creative team that hasn't found the structure where to incorporate into the system. They're super helpful to go there. But I also need to be honest here and say, I try to avoid everything that structure gives me. What we do, and you know it from the conversations we have, I try to circumnavigate every obstacle of the system and we just do it. We get a lot of stones thrown at us for saying, no, this is not according to the system, you need to adhere to the protocols and standards, but we simply do not care and move forward and then hope for the best and the results speak for us. And I think this is something you need in a team, but at the same time you need to go back one step and to then come back together with the superiors and with the system, say, okay, now we have something here that might be of interest, and how can we get it back to the system? To be quick, it always depends on the leadership, because so many times I've heard, no, it's not possible because the system needs years to do it. But the same people all of a sudden were able to do it once the leadership said, I want it. And not by breaking the rules, no, but just accelerating existing procedures. It is possible. And
I mean, Fabian, I think, told us how it can
exactly.
be when the pressure is high enough. So there could be ways of accelerating massively. At what cost does it come? Is also a question. Because if I bring now immediately our technology into a military context, I will violate almost everything. Probably what's there. Security regulations. We are, let's say, cloud native. There are ways of bringing. But I think there's still a very big complexity of having this transfer in a structured way. Because I think the Ukraine is not a structured way of doing this. It's a necessary way of doing this. I think it's out of question. But the real structural way of bringing innovation, I think that's something we are still maybe a bit lacking.
Yeah, I can't talk about all the regulations that can be violated, but I have seen that some of the regulations are created by ourselves, right? And they are unnecessary in terms of, as mentioned before, not all the data needs to be classified. You can work in a sub-classified environment and get the greatest results out of this. And this is a traditional thinking in military. Not in all nations, we've seen differences, or departments. Nations is sometimes too much, different departments. And what I'm trying to say is, if you look at Twitter, for example, or X, you can sometimes see insights or results analysis of singular persons, experts, HR Sutton for the maritime people here in the room, great guys, super interesting to see it, what can be done with the open source data available, but it's not scalable and it's not repeatable. So if one person is doing it somewhere on a computer, it's super and it's interesting, but we need to scale it up into the system. And that's where both worlds still collide. The data doesn't need to be classified, and also in order to get people and companies like you in this environment where you work in, so that they are not need to be prepared for all the regulations, because in my opinion they are sometimes unnecessary. That's one part. And the other part is finding the like-minded people, because also in the different branches and meetings we are in together, and sometimes we are surprised once openly explaining what we are doing, all of a sudden the silent people in the room approach you afterwards and say, we can make it happen. We can make it happen in 60 days, maybe sometimes 30 days. It is possible in the right time, so yeah. Over.
Since I have him sitting here, I would directly continue.
I'm quite happy. I mean, I do want to, again, opportunities for anyone in the room, too, to join this conversation.
Yeah. Okay.
Microphone's right there. But do I see anyone? Oh, we do have a question. Thank you. If it's okay with you, yeah.
Yeah, so my name is Peter Menzel again, and Patrick, in your slides, you pointed out this question of data fusion and how to get all the data together. We talked about this yesterday for the industry. We have the same question. My question to you now, or both of you, is we talk about data formats and how these make standardization and so on. This is a long process, and we will never ceases, I think, 50 years or so. However, do you have any solution? And if yes or no, however, how to fuse and get the data together? And who do you think is responsible to do this? And how can we come to a quick solution for this, to get the different data sources somehow unified, to get a situational awareness image or something like this in a short time from now? Or do you already have this?
No, we do not have this. And sometimes actors in this environment tell us via API, for example, the filter we approach the different data providers, say, if do you have an API, then we can work together. If not, please do your homework. Once they provide an API and with the documentation, everything, there's still so many loopholes in there, even though it's clearly documented. I'll give you one example. One satellite data provider says via API you can access a whole archive. But if you create the area of interest, you know, the box on your map, too big, there's simply no data. There's no process behind it to signal back that your area is too big. You go to another satellite data provider, different area, but it's nowhere mentioned and so on. And this goes back, they would say, well, we are standardized, we are sending the data towards the format you would like to have, but there are so many obstacles next to these standards still that need to be explored. And that's why, again, I simply can say, always have an IT guy with you and look at it. I know. Last year I thought we have it now with all the documents and API and docs and so on and what else is on the market, and now I find out, no, it's not this way. It's not that easy. But on the other hand, looking at data formats that are still being flying around like 5 years or 3 years ago, we made a huge gap forward to incorporate the different data sources, and people left to me did their homework for us. I mean, coincidentally, the platforms like True Oceans and other platforms like, for example, Synmax, what I've shown before, they have done this. They have done their homework for 3 or 5 years and more. So we need to better explore and scout different teams and companies and research facilities where they are and get them as partners, and to get maybe a standard out there to say, okay, this is how we would like to see it. Yeah, but no, I do not have that one standard right now, unfortunately.
Thank you very much. A quick answer from Jann, and then I'd like to, there are 3 other people standing in line there wanting to ask questions. I would love to get to them. So a quick answer from you?
Yeah. I'm fine. It was,
yeah? Okay. All right.
Okay, so hello, my name is Sebastian Geiger. I'm from Fraunhofer ICT, and my job is a sensor engineer there. So really what I'm doing all the time in the lab is to try to transfer sensor systems from the lab to the ocean on AUVs, for example. So I'm always having a problem how to decide on the data format beforehand, because there's still data systems and sensors you didn't even see before, like electrochemical sensors, for example, that have multidimensional data, multiple methods, and how to approach them actually. How do you solve this problem?
In the end, about integrating format after format after format. Yeah, and this is unfortunately at the moment the only way, and this is I think what Patrick also refers, all the time have an IT guy with you. Because the problem is also, I think that's also what I described and what you also just said. There are all the time new sensors appearing. Yeah? So in the ocean, or I say in space, I mean there is also, but I think we have optic sensors that are there for quite some time. They are more or less standardized. We have synthetic aperture radar, which is also still, it's an image which is coming in, and images are perfectly understood. I think there we have standards. But what you just described, you're creating more of the sensors, you're creating more of this data formats. The complexity when we talk about underwater data, and it's not just multi-beam or hydrographic data in some way, is unbelievable massive. And I think we support at the moment in our technology more than 100 data formats because exactly of this, and we have a list of 100 more, which actually need to be supported. So I honestly can't say anything to you because there's unfortunately also not this standard I could guide you to. You know, so use this kind of standard. I mean, use something that is easy. Use a text format, something like this, that is not proprietary, hidden in binary complexity and this kind of things. Yeah? But anyways, there needs to be a translation into also the cloud world, because also cloud is not sensor. Yeah? So we need a different structure of data that we will need. So from my side, unfortunately, no real solution for this.
Quick comment, join the REPMOS exercise. That's a very good environment, if you haven't been there already, to have a community of like-minded people to just test and get the best results of it.
Okay, thank you.
Good afternoon. Name's Dr. Lee Willett. I'm just a writer about naval stuff. Kind of a question about messaging, if I may. Whether it's countries not wanting to share data between each other, whether it's multinational organisations that have problems sharing data across each other because of different country reasons and stuff, or whether it's industry that has concerns about IP and commercial matters or legal issues or ethical issues or whatever. There's always been a sort of reluctance to share data sometimes, but I guess the current circumstances are changing that. You both seem to express some frustration about the time it's taking to share data. And Commander, you're not the first naval officer I've come across in the last couple of weeks that's got quite pointed about this and underlining the urgency of needing data now. I wonder what you, if it's a fair question to ask you, what would you say at kind of, dare I say, a messaging level about the importance of overcoming these data sharing hurdles in real time so that we can move on to getting the data and then using it rather than talking about sharing it in the first place? So what would you say to tackle those obstacles? Thank you.
Yeah, thank you very much. At least from the experience from the last years working in this environment, I could say it would be very helpful if the people who are saying no might be having a meeting with the other ones with the reasons why no, to determine if that no is really necessary. Because part of the data, as mentioned earlier, is, as it turned out by experience, we just asked, and I'm really annoying on this one, why? And then turned out the data doesn't need to be classified or on the NDA, it can be shared. Some part of the insights, some part of the derivative results, yes, but we do not care about this anyhow because we try to go one step back and try to use the raw data and do the own insights based on different data analysis. So that's only one part of the answer, and go back and ask why. And on the other hand is, we have a lot of data sources already available for many years. Sometimes the data providers don't know by themselves that they are a data provider. They simply have the data flying around, and you need to ask in a different way and how to connect in a different way. And sometimes, as also mentioned, some companies they are selling one part of the data, but are not aware of the other part that they are also having available. So iterative procedures, going back and asking the same question, what can you provide? And furthermore, what can you provide? And really, does it need to be classified or under regulations and so on? We have seen, last one, with different nations that one department, let's say Ministry of Interior, says no. Another branch of the military says yes. You're surprised, why is the military yes for data sharing? The Interior, no. Traffic department saying yes, no, maybe, perhaps. The European Union says here's something. We always need to ask the same question again and again, and all of a sudden it works. So that's my part of it.
I think maybe to answer from my perspective, I think there's a fantasy world about data. Yeah, so this real-time everything doing at once, all data sources together. Honestly, I don't see this happen for a multitude of reasons. And the complexity is about what the politics maybe, and also the high-level ones. I mean, we had actually 2 weeks ago a talk to NATO, and there's an entity that says, okay, we now want to connect all industry ocean data spaces. I said, but which kind of industry ocean data space do you want to connect? Yeah, there is no industry ocean data space that you can connect. Okay, good. So, and that's a bit the fantasy world we are living in versus what do the real end users need, yeah, to fulfill their jobs of ASW or minesweeping or actually building a secure cable or pipeline. Yeah? And I think there's still a very big gap, because there's a complexity that is for sure translated very often into a very easy, simple solution and world. Yeah? And that's why I would call it somehow really a data fantasy world. Partially, that's also not achievable, and it's also creating the wrong incentives, perspectives, the wrong strategies partially, I would say. I mean, we had this big 15 million euro Marispace X project. It was a 15 million euro project, Gaia X project, where the European Union tried to standardize actually with Gaia data exchange in data spaces. It simply didn't work. Yeah? So politics tried to tell informatics what to do and which way to do with political complexities, even on a European level. And yeah, I think that's where the real world is standing.
Thank you. Yeah. It looks like there's a final question, and then we're going to take a coffee break. Go ahead, sir.
Thank you. My name is Uwe Mergner, and as my predecessor, Dr. Lee, I'm also a writer on naval stuff. Patrick, you said we have a lot of data, just wandering around. You, Jann, said the fantasy of data. That brings up, and this is on another conference, I followed a presentation about the liability of the data. Is that an issue? And how do we cope with it? What is your take?
Thank you. Perfect.
I mean, I showed quickly assessing the quality of the data. Now that's, I think, a good example with raw data, and raw is also relative if we really talk deep here. With raw data, you can get an understanding what the initial quality has been. So you can also, liability is a difficult topic, but you can get a better understanding what the data is capable of. The more you, and I would say phrase is neutral, manipulate the data, the less you can in the end also trust it. I mean, we had also this time in offshore wind where there were geomagnetic surveys conducted, and then there was a data hole, and you can nicely interpolate it. And in the interpolated area where there was actually no data, you don't see it in the result. Yeah, the company did something like this to cover some kind of a data gap or data hole, and this happened. So if we talk about liability, we have to go, from my perspective at least, to as raw as sensor-like data as possible if we really would like to assess it. But that makes it more complicated, because the closer we go in the end to the raw data, the further away we go also from standardization again. It's a trade-off.
Yeah, short comment to this one. The confidence into the data, it really depends on several factors. Even though we all are very well aware of the limitations of AIS and how AIS being spoofed at the moment all over the places, we're still using it as a base for maritime situation awareness in security centers, in operational centers, on board, even on our own phone. If we hear something about something has happened in the Baltic Sea or the Black Sea, what we do, marine traffic, right? Or vessel tracker, that's the first thing we open. So even though we are very well aware of the spoofing and tracking, we're still using the same data platforms. So I think it's still in our head that it might be still reliable. The same goes for ADS-B, you know, the flight tracker for planes. But I mean, one thing to mitigate the risk with the different data sources is to add another data source. Really, that's not. There are different AIS data sources, different ADS-B data sources, but one of the slides I have shown earlier with this mesh and puzzle of different data sources, that helps to increase the liability of different singular data sources. And you can see, okay, one data source has problems at the moment, we don't know why, and the others are still reliable. So a good mix of everything might be a solution.
Thank you. Thank you very much. I want to thank our two panelists, Jann and Patrick, for being such sports. With only two panelists, we've had an 85-minute session here, and they helped out a lot, did very heavy lifting for me, making my job a lot easier. I appreciate you taking my role on and coming up with some questions yourself, which I'm sure are much more interesting, and I appreciate the input from the audience as well. Super interesting topic, and we didn't even mention, hardly, maybe just once, artificial intelligence, which many people think, oh, that's going to solve everything. Well, once you've listened to this, maybe not, right? There are a lot of other issues at stake here, but invigorating discussion. Thank you very much, gentlemen. We're going to take a break now, a coffee break, until 4:20. And at 4:20, we're going to hear, we've mentioned the European Commission, we're going to have a representative of the European Commission, a program manager from the European Commission's Director General for Space Industry, for defense industry and space. So But do stay tuned for that. I think that I'm not sure if this person is going to be here. Is this person going to be here, or is this going to be beamed in? I'm not really sure. But anyway, 4:20 sharp. We're going to begin right back in this room. So please enjoy your coffee break. It's going to take place right here in this room. See you back here at 4:20. Thank you.